Have you ever stopped to think about what the true limit of size is when humanity decides to build a machine? We are not talking about ordinary construction equipment, but structures so massive they seem to challenge the very logic of engineering. These are machines that move mountains, dig beneath entire cities, and operate on a scale few people can truly grasp. So what is the absolute peak the industrial world has reached in terms of size and power? Today, you're about to take a journey through the 10 largest and most powerful industrial machines ever built. A steady climb that grows more impressive with every position. Stay with me until the end, because the number one machine on this list completely redefines the meaning of massive. But real quick, I need to show you an incredible product that fits perfectly with this world of machines. This is Lego Technic, a set made for adults and families that puts you in the driver's seat of real engineering. Gears, wheels, axles, and mechanisms that actually work. And the level of detail is unreal. Every piece feels like it was designed to fit down to the millimeter. And you know what's even better? Imagine building this with your son. It's not just play, it's sitting down together, building, watching the mechanism come to life piece by piece, and at the end, you can turn the finished model into decor by mounting it on a wall LED display frame, so it stands out and looks like a true collector's piece. There are tons of models, each one more incredible than the last. You and your son deserve that moment together. The models are tagged right here in the video. Just click and grab yours. Now, let's get into the video. Metso Locotrack LT12113S. Introduced in the early 2000s by Metso of Finland, the Locotrack LT1213S was born at a time when heavy construction demanded efficient mobile crushing solutions directly on job sites. Instead of hauling thousands of tons of raw rock to a fixed plant, this machine brought the processing operation to the material itself, transforming how quarries and large road projects functioned. It is powered by a Caterpillar inline 6-cylinder engine with approximately 12 liters of displacement, producing around 415 horsepower. That power feeds a high-capacity impact crusher capable of processing hundreds of tons per hour, depending on the material. Its high torque output allows continuous operation under heavy load, maintaining productivity throughout long workdays. Top travel speed is just over 1 kilometer per hour, as it was designed for stability and precision rather than mobility. The transmission is automatic with a torque converter, making maneuvering easier in tight job site conditions. It runs on heavy-duty tracks that evenly distribute its roughly 50-ton operating weight, allowing it to function on uneven terrain, loose gravel, or muddy ground. Reinforced structural components and vibration control systems protect the mechanical assembly during constant operation. Visually, it feels dense and solid. In working configuration, it stretches over 16 meters in length, with wide tracks and a steel frame that communicates durability. When operating, the crusher produces a deep, steady roar that echoes through a quarry like rolling thunder made of steel. In practical terms, this machine solves one of the biggest logistical challenges in heavy construction, reducing transportation costs while speeding up material processing. It has been widely used in major European infrastructure projects and around the world, helping define the modern concept of mobile crushing. Even as the smallest machine on this list, it commands respect and shows how far engineering can go when mobility and efficiency come together. And if this is just the starting point, the next machine begins pushing size and power to an entirely new level. Big Bud 747. Built in 1977 by Northern Manufacturing in Montana, United States, the Big Bud 747 was created to meet a very specific need. Large-scale farmers required equipment capable of working enormous fields as efficiently as possible. Agriculture was expanding rapidly at the time, and the goal was simple: build the biggest and most powerful farm tractor in the world to reduce operating time across massive acreage. Under its enormous hood sits a Detroit diesel 16-cylinder V engine with approximately 24 liters of displacement, generating about 1,100 horsepower. That is an extraordinary amount of power delivered directly to the ground. Its massive torque allows it to pull implements over 20 meters wide, something very few machines on Earth can do. Top speed is around 13 kilometers per hour, but speed was never the focus. Steady, relentless pulling power was the priority. It uses a heavy-duty manual multi-gear transmission designed to withstand extreme loads for long hours, giving the operator precise control. Power is sent to all four wheels, each fitted with gigantic tires over 2 meters tall, ensuring traction even in soft or freshly tilled soil. At nearly 9 meters long, roughly 6 meters wide, and over 4 meters tall, the Big Bud 747 looks like a moving building crossing the fields. Weighing more than 45 tons, its mass contributes to stability and consistent traction. The engine produces a deep, steady rumble, reminiscent of mining trucks working under heavy load. In practical use, it dramatically reduced the time required to prepare large farming areas, significantly increasing productivity. It became an icon of large-scale American agriculture during the 1970s and 1980s, symbolizing an era when size and horsepower represented progress. Today it is preserved and still operational, appearing at agricultural events and demonstrations. It remains recognized as the largest farm tractor ever built. And if 1,100 horsepower already sounds impressive, wait until you see what the mining industry was capable of creating. Le Tourneau, L2350. Officially introduced in the 2000s by Le Tourneau in the United States, the L2350 was engineered to set a new benchmark in open-pit mining. The industry needed equipment capable of loading greater volumes of material in fewer cycles, and this wheel loader was designed precisely for that mission. It is powered by a Detroit diesel 16-cylinder V engine with roughly 65 liters of displacement, producing approximately 2,300 horsepower. That immense force allows it to move more than 70 tons of material in a single bucket load, significantly reducing the time required to fill ultra-class haul trucks. Its top speed is modest, around 16 kilometers per hour, because capacity and strength matter far more than travel speed. A heavy-duty automatic planetary transmission distributes power to all four massive wheels, ensuring constant traction even under full load. The structural frame was built to withstand repeated extreme stress, typical of mining operations that run nearly non-stop. Standing over 6 meters tall to the top of the cab and riding on tires nearly 4 meters high, this machine commands attention purely through presence. Its operating weight exceeds 260 tons. The operator works at a height comparable to a second-story building, with a clear view of the loading face. Under full throttle, the engine releases a powerful metallic roar that carries across the mine site. In real-world operations, the L2350 transformed loading efficiency in large mining projects by reducing the number of required cycles per truck. It became a global reference for wheel loader capacity and is still considered the largest production wheel loader ever built. And if we are already talking about hundreds of tons and thousands of horsepower, the next machine steps firmly into the realm of true mining titans. Bucyrus 495HR. Launched by Bucyrus International in the United States, the 495HR was developed for extremely large-scale mining operations, particularly in copper and coal extraction. It emerged during a period when the industry needed to remove greater volumes of material with higher precision and lower cost per ton. Unlike the previous diesel-driven machines, the 495HR relies on a high-power electric system fed by an external power supply. Its drive system easily exceeds the equivalent of 4,000 horsepower, delivering tremendous force to operate its massive bucket. The structure weighs hundreds of tons, and its bucket can exceed 40 cubic meters per pass depending on configuration. Acceleration figures are irrelevant here, since its purpose is stationary digging. But its ground penetration force allows it to cut through extremely compacted rock formations. Movement is handled by wide reinforced tracks that ensure total stability during operation. The electric drive system provides extremely precise control over the boom and bucket movements. When fully raised, it can stand over 20 meters tall, giving it the appearance of a moving building. The long, heavy boom extends slowly across the mining face, while the sound of electric motors and tensioned cables creates a powerful industrial atmosphere. In practical use, the 495HR loads giant off-highway haul trucks, optimizing heavy mining operations worldwide. Its ability to work continuously for extended shifts makes it a critical asset in large-scale mines. It became a symbol of large-scale excavation engineering and helped cement Bucyrus as a global leader in extreme mining equipment. And even this monumental machine is only halfway up our list. The next entry pushes mass and power even further. Hitachi X8000-6. Presented by Hitachi Construction Machinery of Japan, the EX8006 represents one of the major milestones in hydraulic mining excavators. It was developed to compete directly with the largest equipment on the planet in both capacity and durability. It is powered by two Cummins 16-cylinder V diesel engines, each displacing around 50 liters. Together they deliver approximately 3,800 horsepower. That enormous output allows it to handle buckets exceeding 45 cubic meters in capacity. Its operating weight surpasses 800 tons, ensuring absolute stability during digging. Top travel speed is limited to around 2.5 kilometers per hour, since strength and precision in continuous operation are the true priorities. The hydraulic system is extremely powerful, enabling smooth and controlled movements even under full load. It rides on wide tracks designed to spread its immense weight across the mining surface. Visually, it is imposing. The main structure alone rises over 10 meters high, and when the boom is fully elevated, its scale becomes even more dramatic. The operator sits in a raised cab with panoramic visibility of the extraction area. When both engines are working under load, the combined sound creates a deep and steady rumble. In practical terms, the EX8006 reduces the number of cycles required to fill ultra-class mining trucks, increasing operational efficiency in coal and iron ore mines around the world. It solidified Hitachi's position as a global leader in ultra-large hydraulic excavators, proving that Japanese engineering stands among the best in the world of giant machines. And we are only halfway through. The machines ahead move into even more extreme territory. Caterpillar 6090FS. Introduced by Caterpillar in the United States, the 6090FS was designed for mining operations on a truly monumental scale. Its development focused on moving enormous volumes of material in as few cycles as possible, reducing operational costs in high-output mines. It features two 16-cylinder V diesel engines, each with approximately 65 liters of displacement. Combined output exceeds 4,500 horsepower. That tremendous power drives a front shovel bucket with capacity over 50 cubic meters, moving massive quantities of material with each pass. Operating weight can exceed 980 tons, ensuring maximum stability during excavation. Top speed is around 2 kilometers per hour, because steady force and precision matter far more than mobility. Its hydraulic system is extremely robust, delivering smooth motion even under full load. Heavy-duty tracks distribute nearly 1,000 tons across the mine floor. With more than 10 meters of height in the main structure and a boom that towers over 300-ton class haul trucks, the 6090FS radiates pure mechanical authority. The sound of both engines working together produces a deep, continuous industrial roar. In operation, it loads massive off-highway trucks in large copper and iron ore mines. Every bucket movement represents productivity on a gigantic scale. The 6090FS became a symbol of Caterpillar's dominance in ultra-class hydraulic shovels. If you are impressed so far, take a moment to like the video, subscribe to the channel, and turn on notifications so you do not miss what comes next. Because from here on, we move into machines that go beyond diesel power and into the world of colossal electric mining systems. Komatsu P&H 4800 XPC. Developed by Komatsu of Japan, the P&H 4800 XPC is an electric rope shovel engineered specifically for large-scale mining. It was created to deliver extreme digging force with high energy efficiency in operations that run around the clock. Instead of conventional diesel hydraulics, it uses high-voltage electric motors. Its drive system can exceed the equivalent of 7,000 horsepower, delivering monumental force for cutting through dense rock formations. Operating weight surpasses 1,400 tons, placing it among the largest excavators in existence. Bucket capacity can exceed 60 cubic meters, allowing ultra-class trucks to be filled in very few passes. It moves on massive reinforced tracks that provide complete stability. Steel cables control the boom and dipper with impressive precision. When fully raised, it can stand over 20 meters tall, dominating the mining horizon. The sound of electric motors and steel cables under tension creates a distinctive industrial rhythm. In practice, it is used in major copper and coal mines where continuous force and efficiency are essential. Electric operation reduces direct fuel consumption and provides consistent performance over long shifts. This machine represents the evolution of rope shovel technology, blending traditional concepts with modern engineering. And yet, even this giant is not the largest on our list. The next entry takes us into true industrial legend territory. Big Brutus. Built in 1963 by Bucyrus Erie in the United States, Big Brutus was designed for open-pit coal mining in Kansas. During a time of rapidly growing energy demand, the industry required machines capable of stripping vast layers of overburden with relentless strength. Big Brutus is an electric-powered rope shovel supplied by high-voltage external power. Its system delivers the equivalent of roughly 5,000 horsepower, enough to operate a bucket holding about 90 cubic meters of material. Speed was irrelevant. Consistent digging force was everything. Its total weight exceeds 5,000 tons, making it one of the largest machines ever built in its era. It travels on massive tracks engineered to distribute its enormous weight across the mine floor. Steel cables control the boom with remarkable accuracy for a machine of this scale. Visually, it is staggering. The main structure rises over 48 meters tall, comparable to a 15-story building. As the boom moves slowly across the terrain, the sound of electric motors and tensioned steel fills the air. In operation, Big Brutus removed massive amounts of overburden to expose coal, sustaining regional energy production for years. Eventually retired, it was preserved as a historical landmark and now operates as a museum. It stands as a monument to an era when size and horsepower defined industrial ambition. If a machine from the 1960s could reach that scale, what comes next takes underground engineering to an entirely different level. W.Burt SR99 TBM. Designed by Hitachi Zosen Corporation in Japan and operated by the Washington State Department of Transportation in the United States, the machine known as Bertha was built to excavate the SR99 tunnel beneath Seattle. Its mission was to bore through miles of urban ground with extreme precision. Bertha is a tunnel boring machine powered by an enormous electric system. Its motors and drive assemblies exceed 25,000 horsepower equivalent, turning a massive rotating cutter head. The cutter head measures about 17.5 meters in diameter, wider than many residential buildings. Total machine length exceeds 99 meters, nearly the length of a football field. Weighing over 16,700 tons, it advanced slowly, cutting through soil, clay, and rock, while simultaneously installing tunnel lining segments. Inside, operators experienced constant vibration and the steady grinding sound of earth being carved away. Bertha ultimately completed a vital underground highway tunnel, replacing an aging elevated structure and reshaping Seattle's infrastructure. It demonstrated that cities can be excavated from below without completely shutting down life above. And yet, even this underground giant is not the largest machine humanity has built. The final entry operates on a scale that is almost impossible to comprehend. Tackraft Bagger 293. Built by Tackraft in Germany, the Bagger 293 is officially recognized as one of the largest land machines ever constructed. Designed for open-pit coal mining, it represents the absolute peak of large-scale continuous excavation engineering. It is fully electric, powered by high-voltage external supply, delivering more than 16,000 horsepower equivalent. That energy drives its enormous bucket wheel, capable of removing up to 240,000 cubic meters of material per day under optimal conditions. Its total weight exceeds 14,000 tons, heavier than many naval warships. Length reaches approximately 225 meters, and height surpasses 90 meters, comparable to a 30-story building. It moves on multiple tracked assemblies that distribute its incredible mass across the mine surface. top speed is under 1 kilometer per hour because continuous excavation is its sole purpose. The rotating bucket wheel at the front turns steadily as dozens of buckets remove soil and coal without interruption. The deep, constant sound of electric motors and steel in motion creates a hypnotic industrial presence. In operation, the Bagger 293 strips surface layers in German coal mines, exposing material for extraction. Its enormous capacity reduces the need for multiple smaller machines, concentrating productivity into one colossal structure. It entered the record books as one of the largest mobile machines ever built and stands as a symbol of mining on an extreme scale. For many engineers, it represents the practical limit of what can be constructed on solid ground. Today, you have seen machines that do more than impress with size. They redefine what becomes possible when engineering meets industrial demand. From gigantic tractors to city-boring tunnel machines, each one transformed heavy industry in its own era. These steel giants are more than equipment. They are monuments to human ambition. Now tell me in the comments, which of these machines impressed you the most? Which one would you most like to see operating in person? And which do you believe represents the true pinnacle of industrial engineering? If you enjoy this kind of content, make sure to like the video, subscribe to the channel, and turn on notifications. That support helps the channel grow and allows more people to discover these incredible machines. I will see you in the next video.